afternoon, good evening, depending on your time zone. I am Domenico Mangiacapra. I'm the CEO of Henshin Group. Luca?
Yes, Luca Salvadori. I was involved from Domenico in this adventure. I'm, let's say, coordinating this big ecosystem, blockchain ecosystem that we are trying to build. So, Domenico, please go on.
Yes. So, our speech before the Q&A session will be divided in three parts. The first part is a presentation of the architecture of our platform. And the second part is the presentation of live use cases of the platform on the road. And the third part, the most interesting part from my point of view, is the representation, discussion on about what we are doing now, what we are working on. And so, first of all, who we are. We are Henshin Group, that is a very young company. We were born in 2018, and we started developing our platform that was ready on the market at the end of 2019. So we had the first customers on the road during 2020. And the most important things, considering this year, is that we had the integration with BMW Cloud and for connected vehicles. We have had also the full integration with Autonomous Cloud, and we are working with the integration with the cloud of some others OEMs, probably before the end of this year. And we had some rounds of investors, mainly focused on the energy environment, energy field. Now we are doing a third round. So the general philosophy, the general vision of MOVENS, and the general vision of MOVENS is very well represented by the title of this press release of Volkswagen in 2018. And it's very clear that the future will be managed by integration of different technological platforms, but all the technological platforms are not equal because of the mobility platform as a real higher level of technological intensity inside. If you think only to the technology that is inside an autonomous vehicle, a single autonomous vehicle, it becomes very clear that the intensity of the mobility platform is higher than all the other platforms. It means that in the integration between different platforms, the mobility platforms will become the hub of all the other platforms. And so it will evolve into a central hub of all the smart city services to citizens. And so with this vision, we have developed MOVENS as a mobility platform designed to be the hub of all the services of a smart city. Starting from mobility, that is the first circle, the blue circle, and then with energy and buildings, the second circle, and now there are development on other circles connected, for example, about financial environments, insurance, banking, and then health, and so on. So we have developed MOVENS with this architecture. And obviously, if a technological platform has to be the hub of the smart city, of all the other platforms, it absolutely must be completely open source, because of the platform must be designed for integration, for example, and integration requires to be open source in order to guarantee a correct time to market for the solutions. So, what are the main pillars of MOVENS? First of all, it's completely open source. And if you go on our website, you can download all the source code. And it adopts the, we can say, the cutting edge technologies currently. And because of it is open source, all the technologies will evolve in the future in a very easy way. It's completely designed for integration. It's designed to be an hub. It means that it's quite easy to integrate existing solutions, existing platforms. And we adopt only standards in our platform. And because of, if a platform is designed to be an hub, it must be adopt all the standards and in order to become a standard. And for that reason, because we completely agree with the MOBI vision, and we are part of MOBI. And our job now, we will see in the third part of the presentation, is to introduce all the MOBI standards in the platform. And this is the architecture. The architecture is split in 2 slides because of it's very large and it is difficult to show it in a single slide. And this is the main architecture for the mobility, strictly mobility platform. And it is based on microservices orchestrated by Kubernetes. This allows MOVENS to be agnostic versus the cloud. So we have current installations on Google Cloud, on Alibaba Cloud, on AWS, and the platform can be supplied as a service or can be installed on the customer cloud. And because of we are an open source system, usually the services to the customers are made through a network of partners, usually system integrator or big consulting companies. And so, depending on the customer, the platform can be installed on any cloud because of Kubernetes and all the data. So the common part of all the verticals of the platform are managed by Kafka. We use Kafka as a message bus. And so here you can say the mobility component while here you can say the what can I say, the field component, so the component that is used in the energy environment, where we use Kafka as a message bus, and we collect data from sensors on the field. Sensors can be inside the vehicle. Later we will show you live some of these applications, and usually the platform is absolutely agnostic on the device. There are specific drivers for devices or sensors, and this is the reason because of, for example, in the mobility field, we connect through connected vehicles in order to be able to give services without installing any kind of box inside the vehicle. And this is the reason, for example, for the integration we have made with the BMW Cloud. And also on the database side, we have an abstraction layer. And so, for example, here, the standard open source solution is released with MongoDB, but we have customers that are working with Cassandra, for example. So we are not strictly connected to a specific database. All the system is designed for integration. It means, for example, that we have more than 500 API already available directly on our website. And so all the systems, also all the communication inside the system, are completely managed through API. And all the API environment system is increasing week after week, because we are increasing the network of the partners that are working with MOVENS. And so hundreds and hundreds of API are already available. This permits a very quick integration with other solutions. So all of this is already live, and now we will show you the existing MOVENS on the field. So currently we can consider that we have three main verticals: in the mobility field, in the energy field, and in the insurance field. In the mobility and the energy field, these verticals have been developed directly by Henshin, working directly with the customers, while the vertical in the insurance field has been developed directly from one of our customers, that is a German insurtech. And so the vertical has not been developed by Henshin, but by WeFox based on MOVENS. And so now I will show you in a very quick way some of them. For example, the sharing vertical is a cloud-based, obviously, system. In this case, it is based on Google Cloud, and it is better. I will show you live. So I will show you live here. Okay. This is, I'm showing you live now. This is a sharing operator in Ljubljana. Ljubljana is in Slovenia. a European country, ex-Yugoslavia country. This is live. In this case, we are using connected vehicles. They are Chinese electric connected vehicles produced by Geely or Geely, and that is a Chinese car maker. And here is live the situation. Obviously, if I click on a specific vehicle, I have all the data of the specific vehicle, and we in this case, because of we have all the data of the connected vehicle, we have not installed any kind of box inside of the vehicle. We connect directly with the vehicle, and you can see here I choose a trip, for example, maybe this one. Obviously, we have all the detail of the trip, but most important, we have all the events during the trip, changing of the gear, front, retro, and so on, open door, closed door, and so on. So we have the position of the map on any event. This is fully configurable. And I return to the presentation. And these are also some other solutions. Some of you maybe have seen the Lotus solution. Lotus is a car maker owned by Geely. And this is a very important application to understand how the platform is designed. This is a complete different application. This is an application for public transportations. Local transportation inside the city, buses, and also outside of the city, so coaches. And this application that I show you live is an application for a local transportation authority in a region or in the northeast of Italy. And you can see here, these are the stops. This is a wide area. So we go, for example, here there are 100, here are 11 stops. I choose maybe a specific stop. I have all the data, all the lines, all the routes that involve this stop. I can select the stop I want, and I can select the specific route and so on. All the system involves also the smartphone application for users, and this application it's used mainly for the COVID restriction. I mean, the user can reserve his trip saying, I will take the bus at this time, at this stop, to go in this place. So the local authority knows exactly how many people will enter a bus at the specific stop and how many people will exit the bus at the specific stop. So for example, in the time of COVID restrictions, that, for example, in this area was the restriction was 50% of the people can enter the bus. I mean, that if the capacity of the bus is of 100 people, only 50 people can enter the bus. So the problem from local transportation was in peak times to guarantee the same service level. And to do that, in peak time, they had to add new buses or new coaches. And but they didn't know where and at what time. With this system, they know exactly when the limit will be reached, and so they know exactly at what stop and at exactly what time they have to add a new bus in order to guarantee the transportation capabilities. It's used especially in this area for school transportation, because the peaks are reached during school timing, entering and exiting the schools. What's very important about that? First, it seems that it is very different from the sharing solution that I showed you before, but it has been deployed putting together in a different way the single blocks of MOVENS, and obviously developing some other specific blocks. And the time we needed to develop this solution was around 1 month. 1 month is very important because you can understand how wide, you can understand the amplitude of the modules that currently are part of MOVENS. And the second important feature of this solution is that is completely based on the standards. And in that case, on the GTFS standard, it is a Google standard, and about all the cities, all the local transportation authorities in the world publish their data in this format. It means that this solution is immediately working on any local transportation you have on the world that is using the GTFS format, that now it is used by more than 90% of the solutions. And it's completely open source. So I come back to the presentation. Sorry. Okay, I come back to the presentation. So here are some screenshots. So another application is has been made by a research institute. This is the Politecnico of Milano, to develop remote driving. Remote driving, so the remotization of the driving, is very important in the context where you have existing vehicles, a large number of vehicles, and they use remote driving in order to relocate during the night, for example, the vehicles of the fleet. Remotization of the driving is very important because is really cheaper than transforming an existing vehicle in an autonomous vehicle. And in this project, the value of the hardware, of the costs you have to remotize the vehicle is around 1,000 euro for each vehicle. And this cost is lower than the cost you have if you need a logistic team of real people that, for example, during the night go around the city or around the geographic area to relocate the vehicles. These are some slides of this. And another application of MOVENS, so we are talking always about the same core, using the blocks in different ways, and obviously many times developing new blocks. And is the remotization of the batteries. Better, the remotization of the battery management systems in vehicles. And also here, I can show you live. So I go live. Okay, here, for example, we have, this is a Goupil electric truck. Goupil is a French truck maker, and they are owned by Polaris. And in that case, these kind of vehicles of trucks are used mainly for waste collection inside the cities. In that case, you are looking at live data of a Goupil truck. And here we have the full remotization of the of their battery management system. So here you are looking at the data, for example, of the voltage of the battery. This is the temperature. It is quite constant. Obviously, I can select any interval, and so you have all the data during time. But here we have all the detailed data of the batteries in order to manage all the support to these batteries, and we are able, better, the customer is able to make all the predictive activities, so to act on the customer before the issue appears. And to show you, for example, here I choose, for example, a Nissan. This is a Nissan Leaf. And as you can see here, in this case is a lithium battery. We have, for example, the voltage of every single cells of the vehicle. In that case, in the Nissan Leaf, the batteries have 96 specific cells, and we have the data of every single cell. Now I select, for example, a time interval. Okay, and for example, this is the voltage of the cell 63, and with this kind of details, so the complete remotization of the battery management system, you can do all the predictive maintenance. In that case, we have already integrated, for example, an AI system developed by BIOS Digital, and so with this gateway that is working on the data, we have all the anomaly detection, and we have in this case the red circles are the anomalies in the past, but we have also predictions of the anomalies in the future. So, okay. So this is live, and another application that is starting in these days is a complete monitoring, not only of the vehicles, but not only of the electric vehicles, but the interaction of these electric vehicles with the building. So we manage the electric vehicles, the wall box, and all the energy sources, all the energy devices in the building. This is the base of the energy community management. So this is the state of MOVENS now. And all of these solutions are continuously evolving. And so now we will discuss with you on what we are doing now, what we are working on, what's new. And we are working on the market. So we are working on the requests coming from the market. And the main problem on the market now that we see is that the increasing of renewable sources of energy is increasing very fast, but is this increasing is being creating an issue about the grid balancing, because you have absolutely no control about the quantity of energy that is created by renewables, because wind can be or cannot be, can change in single time. So the grid balancing is very difficult to be managed with the new energy sources. And so the management of the grid balancing will be done more and more through storage systems, through batteries. And the technologies to do that, the technology to manage batteries, to manage storage, is the technology, the same technology that you use to manage batteries in electric vehicles. The same technology you manage for the vehicle to grid. So the vehicle to grid technology, so the standard of MOBI developed about the vehicle to grid are the same standards, so the same technologies that are being used in the building to grid and more in the, generally speaking, energy balancing. So now we are working using the mobility solutions in the energy field. These are some data about the storage market in the future, and that is increasing very fast. And here you can see their role in the grid balancing. It's a huge market, and by a technological point of view, it's a collapse in one solution of different technologies: transport sector, power sector, and battery industry. And this collapsing creates a very big opportunity in the market, with the storage universe in the center. And so we are working on that, starting introducing the mobility standards by MOBI in our platform. So now we speak more by a technical point of view, and I let Luca speak.
Okay, so thank you, Domenico. My role is to try to let's say explain what we are doing right now, because as Domenico mentioned, there is a very strong focus on the battery, and so we took this as the opportunity to develop a proof of concept on the battery life cycle certification model. That's our ambition. So basically, what we want to do with this project that is just started, we want to develop an initial prototype for a distributed battery certification network. with a goal, with a very important goal. Our idea is to try to achieve this result of producing an instant battery health certificate, of course, using blockchain, DLT blockchain technology. So we define two major objectives here. One is the development on the on-chain, so meaning the development of new protocol for certifying the health status of the battery. The off-chain objective is the creation of a web app for the moment. Probably in the future there will be also native apps, but let's start with a web app. This is going to allow the actors of the distributed network to interact. And then I will tell you more, because there is also call for action for participating if someone is interested. Of course, the final aim is that these on-chain and off-chain solutions will become a sandbox available for experimenting, for other partners to join the network in order to further scale the concept in the energy sector, we hope at the global level. That's, let's say, the major focus of the proof of concept. Please, Domenico, the next one. So we will focus. We are already starting in reality, but major focus are with the early phase of the project. The results area, the key implementation results areas are the following. So, of course, the battery, for the reasons that Domenico just explained to you. We see the battery, we will see also later a couple of slides where we have the battery for us is a central say system, is an important system, as well as the vehicle identity. And we really want to leverage our experience that you have seen in one of the latest implementations. So regarding the battery, the key point here is to find the solution to trace the operation between the battery and a battery management system. Probably you know that there are several battery management systems, so is a challenge by itself, this one. But I think we have accumulated some experience exactly on this. However, this is a very important and crucial area, implementation area. Then the second item, the second point is the charging system. So we need to identify the solution here to trace the operation of a battery management system and a charging system. For instance, there are many questions, many challenges here, many tech challenges as well. So how and what detail of data can be communicated, for instance, how to translate them into traceable events, and many more. Then the third area is the state of health method. So the idea that we are bringing with this project is that at the end of the story, we noticed that there are different methods for measuring measuring the state of health of a battery. Of course, the ambitions here is to integrate them into our protocol, meaning to be agnostic and to use the most important method based on best practices available on the market to determine the state of health of the battery. So here I can say that we have already seen there are several proprietary notes, but also some best practices available to everybody. So itself, this area is a project. But of course, we will try to follow, I mean, our vision to keeping everything in a well-designed ecosystem and open source. Then regarding the actors of the distributed system. So we have already identified into the distributed network the main, what we believe are the main actors that are doing certain activities during the life cycle of the battery. And so these are important to, for us, it's important to identify the activities of these actors in order to understand what are the key traceable events that then we want to record, to register into our blockchain. So next, please. So regarding this proof of concept project, there are three major aspects and assumptions that we took basically, and where we will have the focus. The first one, of course, is the DLT. So we have done several investigations here, several discussions also between us. At the end, for the proof of concept, the intention is to use the Hyperledger. Probably, most probably, because we had the support from Oracle, we will go with the Oracle blockchain manager infrastructure that is using the Hyperledger. That's, let's say, for the proof of concept. Clearly, we expect also different technologies once we will go out the experimentation period. Regarding the actors, as I was saying before, we have already identified several different actors that are somehow involved, somehow or really involved in events generating meaningful data. But clearly, this is an area of further investigation from our point of view that is necessary in order to better understand really what are the key events during the life cycle of the battery. Of course, regarding the processes, we have seen that we can summarize in three main processes here: production, waste, and usage, or usage and waste. We will focus only the production and usage for this POC. And waste, we will take this into analysis in a later phase. So next, thank you. How we are going to approach this project? So the approach will be an agile prototyping approach, fully. I mean, in the reality, this is a project we can consider it as a research and development project. So we thought to have three major three major steps in the development. An important area of modeling, what we are already now. We started with a high-level concept of the network, but now we are really entering into the more detailed analysis phase. Then, of course, we will take care of developer integration. And then the final step will be the demo open to various actors in order to get the feedbacks and further develop this new solution that we are bringing to the market. Next, please. So here you have to spend maybe a few minutes more in order to tell you something more about how we envisage, how we plan this proof of concept project. So basically, the idea is that in less than 6 months, we should have the sandbox ready. So in terms of managing the project, of course, there will be project management directed by us throughout all the duration of the project. And we are going to establish a project steering committee with the various stakeholders involved. The project steering committee will meet around about every 5 weeks during the implementation, and then we will have a final steering committee. This is necessary because the actors that are involved, the methods, the state of health methods, and let's say the various implementation areas, the key everyone is a project in the project. So we really needed to approach this aligning continuously the stakeholders. Of course, the modeling phase is not just an initial phase. Modeling will be reiterated during the project several times. And then, of course, the project will start after the modeling. Soon after the modeling, we will have the prototype infrastructure set up, and then we will enter into the real thing. So the focus here will be to create an integrated global model. This will be the basis for the protocol that we are going to develop. Of course, we see this like a continuous improvement integration process where the global model will be constantly refined throughout all this research and development project. Of course, the key of the development, the integration will be the work on the 4 components, the battery, the BMS, the charging, the method, and of course then the outputs will be one on-chain on the technology that I explained to you before, and off-chain, as I said, we will start with a web app, but probably in the future there will be also some native apps. With the goal to have to open up this sandbox not only to the current working group, but also to other interested to join us. Next, please. So, coming back to the battery. So we see the battery identity as playing a central role in our let's say vision. I mean, everybody knows that there has been a great focus, a big focus on the vehicle identity, but we see the battery identity as an enabler for many different opportunities here, either a governmental level, a car maker, owner. So we see playing the battery identity, playing a role, a central role in the connected energy ecosystems. That's why there is, from our point of view and from real experience on the field, this big focus on the battery, and then we open up, we conceive this new project. Next, please. So, what are the key advantages of this approach? Of course, there are advantages regarding the battery identity itself, and then the battery life cycle certificate. So clearly a battery identity, an established battery identity, it allows to trace the entire life cycle of any type of battery. Of course, we said that we are going to design this using blockchain technologies. The other thing that we expect is that it enables the certification of the entire battery value chain. This is the final aim at the end of this proof of concept. And then there are also other aspects regarding the battery life certificates. I mean, here it's really, we expect to boost the economic value creation. I mean, we go into the circular development model here, tracing all the big events during the entire life cycle of the battery. The first life, the agnostics, the refurbishment, the second life, recycling, and then life. So we see big opportunities having such kind of system. Of course, then we want to contribute to optimize the energy management processes in almost all phases of the value chain. Sorry. So that's, let's say, the main advantages that we expect from this project. Next, please. Of course, this is opening up an entire new business opportunity world, because through this approach, you can basically think of having a battery identity supporting a new generation of connected energy services. So everybody knows that there is a lot of, I mean, a big talk about from cloud to edge, and everything that this is implying in terms of changes in infrastructure, changes in the way of doing the things and working. So we believe that this is going to support all this new, let's say, what is going on technology level. We expect to allow to interact and transact directly with grid infrastructure, or with positive energy districts. This is the picture is depicting one of these as an example. And then, of course, we expect that the battery identity permits to the stakeholders to verify identity, credentials, and all, of course, associated metadata without so much troubles. This is what we think we are bringing here as a new opportunity, a new interesting project. Next, please. Of course, there is a call to action for you. So now the working group is made by Henshin, Oracle, Soprasteria. There is a global leading car manufacturer that has approached us, is very interested to join, as well as a leading energy company. Of course, there is a place for everybody. We really would like to enlarge this working group in order to get and share all the possible experiences and know-how in order to bring this concept to the highest possible level. That's our aim. So I think we have said everything here. I think it's the time for query and answers. Yeah, I saw that there were some questions from your side. So we still have some minutes available. So please, if you have some questions, we are here.
Yeah. Thank you so much for your lecture. Yeah, we do have some questions in the chat that I can read. So our first one, without having any module in the vehicle, how is it connected to the cloud? And which module of the car is your open source platform library? Or which module does it get installed in the car? I think that's the first question.
Okay, so it depends from the service you give to the market, you give to the citizens. So when we connect the MOVENS cloud with the car maker cloud, we are depending on the data that the car maker collect. And so it's very easy if you have to give, for example, sharing services, mobility services, because they give you the possibility about all the car makers, the possibility to interact with all the data that are on the CAN bus. And it's more difficult, and it's the cloud to edge problem, if you have to manage the powertrain data, the battery data, the battery management system, because often not all data are on the CAN bus. The detailed data, for example, the single cells data, a lot of times are not on the CAN bus, but they are on the CAN bus only if you ask for them. So in these cases, usually you have to install a specific box on the vehicle. So you get the data directly from the connected cloud, if data are simple. If data are detailed, currently, with the exception of very few car makers, for example, Tesla or NIO, with all the other, you have to install a specific box for the detailed data of the battery. And the vehicle, if it is a connected vehicle, it's connected to the cloud directly by the car maker. So in the production line, they install also a device, a technology that sends the data to their cloud.
Great.
So you tap into their cloud and get the data, or you provide the data format or the ontology, what each and every OEM has to follow?
Yes. So we have MOVENS support both cloud-to-cloud connection and cloud-to-vehicle connection. So we have both cases depending, and sometimes with the same car maker, we have both the solution, cloud-to-cloud and cloud-to-vehicle, especially if they need very detailed data.
So in the case of cloud, vehicle to cloud, how does that work without having your own module, or any implementation goes into the vehicle based on your specification? That's where I got disconnected when you said we get data from the car without putting any module. And of course, when I go to the download section of your website, you do have some libraries for the what do you call, the tar version, and the GitHub location also given. So I was wondering whether with the V2C communication, OEM has to put or install your library SDK into any specific module, what it opens up the gateway to the cloud was my question.
Yeah, yes, and when talking about car makers, usually we develop together with them the specific, what can I say, driver or firmware that must be working on the vehicle, and then they are the owners of this specific part of code, and they use it to send data first to their cloud and then to our cloud. And I don't know if I answered to your question.
Mostly, okay, you kind of support both. If they don't have their own cloud, we have to work with you and use your infrastructure or whatever cloud platform you are using.
Yes.
Or if the OEM has their own cloud, you support different data formats provided by different OEM between your cloud and their cloud.
Yes, I'm very happy to have a call, a more detailed call with you about this topic with our technical team.
Thank you.
Yeah, thank you. So we're actually at time, but thank you so much for answering some questions. And thank you so much for your lecture. As I said earlier, this is recorded, so it'll be on our website and also available through our bulletin. So make sure you subscribe to that. And yeah, again, thank you so much and have a good rest of your day, everyone.
Yeah,
okay.
And there's one more question from me, that in addition to MQTT, what other protocols support?
Mind taking this offline? We're going to end the lecture today. Thank you so much.
All right. Thank you.
Thank you. Thank you.